More practice on solving by elimination. Solving a system using multiplication and subtraction. Most often you will find that the two equations you're given cannot be solved with just one simple step of adding them or subtracting them. You're going to have to do an intermediate step to get one of the variables to match up to be eliminated. As before, I start off by writing both equations in the same form, one above the other, and I number them. Now I'm going to look at them and figure out what could I do to both equations to get either the x variable to disappear or the y variable to disappear. If I look at 3 and 4, if I multiply those together, I get 12. So if I had 12x here and a 12x here, I could subtract them and get rid of the x. Alternatively, I could look at the 2 and the 5. I could multiply this equation by 5, that would give me a 10y, and I could multiply this equation by 2 to give me a 10y, and I could eliminate y. I'm going to choose to do x. So I'm going to multiply the first equation by 4 and the second equation by 3. I'm going to multiply every term by that number. First thing I do is I indicate what operation I am doing. So I'm going to write equation 1 times 4, and now I do the operation. 3 times 4 is 12, 2 times 4 is 8, 2 times 4 is 8. Since I have multiplied that equation by a number, it's now a new equation. I'm going to renumber it equation 3. I will now do the same thing with the second equation. I'm going to multiply equation 2 by 3. So 3 times 4 is 12. 3 times 5 is 15. 3 times 12 is 36. Since I multiplied this equation by a number, I'm giving it a new equation number 4. Now I draw my line. I can now eliminate x. And I can do it by a subtraction. I can go 12 minus 12. I can do it either equation 3 minus equation 4 or equation 4 minus equation 3. I don't tend to like to deal with negatives, so I'm going to do my subtraction such that I have as few negative numbers to deal with as possible. If I go equation 4 minus equation 3, this subtraction will give me a positive number, and this subtraction will give me a positive number. It saves me from having to divide by a negative number at the end. So if I go, I'm going to write down the operation. I'm going to write equation 4 minus equation 3 and now do it. 12 minus 12 gives me a 0. 15 minus 8 gives me 7y. And 36 minus 8 gives me 28. I can now divide both sides by 7. And that gives me y equals 4. That's the y coordinate of the solution to the problem. We will now use that y value in one of the two equations to get the x value. So I'm going to substitute y equals 4 in equation 1. So I've got 3x plus 2y equals 2. That's my equation 1. I'm now going to plug in the 4 for y. That gives me 3x plus 8 equals 2. I'd like to get rid of that 8, so I will subtract it from both sides. I get 3x equals negative 6. So if I divide both sides by 3, that will give me x equals negative 2. The solution to the system is negative 2, 4. But I may have made a mistake, so I'd better check it in the other equation to make sure it's the right answer. So I'm going to check this equation in equation. I'm going to check the solution in equation 2. Just use a left side, right side check. I've got 4x plus 5y equals 12. Now I'm going to plug in negative 2 for x and 4 for y. 4 times negative 2 is negative 8. 5 times 4 is 20. And if I add them together, I get a 12. 12 on the left is equal to 12 on the right. Left side equals right side. This is the correct solution to the given system. Thank you for visiting this lesson.